Hello, we are two students in the Math 135 class at the University of Toronto with a project of modeling population growth in our hometowns. My name is Maya and I am from Tiverton, Rhode Island.
I'm Angela. I'm from Montreal, the second largest city in Canada.
So the two populations are very, very different size-wise. Tiverton has less than 17,000 people living in it, while Montreal has over 4 million. To model Tiverton's population, I decided to find the growth rate of the past 20 years and multiply that by the years from 2023. This is a power function.
And for me, to model Montreal's population, I performed computation by hand in the textbook to get the overall population data in the past 15 years, and obtain the best model that fit the data using decimals, in which is an exponential function.
So on these graphs on the left, we have the same scale for both of our functions, but with 3.5 million units different vertically. So in blue, we have the growth of Montreal, which obviously has a much steeper slope than that of the red graph, which shows Tiverton's population. To further show this, we went on to find the derivatives of both of our functions, in which, as long as the time is less than 1,000 years from 2023, the growth rate of Montreal is much steeper than that of Tiverton.
Our model have some differences and similarities. For the similarity, we use the same factor for the development of model, birth, death, immigration, and emigration. And both our model predicts a positive population growth. And for differences, Maya used a power function, while I used an exponential equation. Tiverton's population is significantly smaller than that of Montreal, and to be precise, Montreal is 228 times larger than that of Tiverton. Maya plot the data with each factor to find the growth rate, while I plot the overall population data to find the model.
Okay, so both of our equations have some pretty obvious shortcomings. For one, the farther away from 2023 we are in time, the less accurate our equations become, because we are only using data for the past 20 years rather than for the past 50 or 100. On top of that, Montreal has some space constraints as they do not have unlimited housing, which could eventually limit the immigration rate into the city. And Tiverton has a very large elderly population, which is causing a lot of older people, which could lead to a population bottleneck and a sharp increase in the number of individuals in the future.
To determine which model is more accurate, in 2050 and 2100, we calculate the percent difference between the theoretical population by the model and the actual population. We can see from the data here that the percent difference from the population data in Tiverton is much smaller and consistent. In conclusion, the population growth model of Tiverton is a more accurate predictor of the future growth when the two models are compared to their percent difference and looking at cultural restraint.
Okay, thank you so much.
Thank you.
These are our works cited, and have a great day.